Hey guys, Rob here at 3D Printscape. Today I'm going to show you how to change the nozzle on your 3D printer. So let's go ahead and get started. Alright, let's go ahead and power it on. So I actually have a jam on the nozzle right now, so I'm going to take it all apart, and I figured since I was doing that I might as well show you guys how to do it and then replace the nozzle while I'm in there. Alright, so let's go ahead and heat the hot end. So we go to prepare. And actually, first thing we're going to want to do is disable steppers. Anytime I'm messing with the extruder, I'm going to do that just to be safe. So we'll go ahead and do that. Then preheat the hot end. Alright, so while that's heating up, make sure you guys smash that like button and subscribe. Alright, so while that's going, let's go ahead and take a minute and talk about why you're going to want to replace the nozzle. Here I have a copper nozzle. That's just a 0.4 millimeter. The copper is very soft, and the actual filament going into it is an abrasive, so it's going to eventually increase the diameter of the actual hole, which will impact the flow rate of the filament coming out. With the PLAs, it's not as abrasive. It's a much softer material, so it's not as critical. But even if you don't have a jam, you're still going to want to swap them out maybe once every 6 to 12 months when you start noticing a degrade in your print quality. If you're working with ABS, I would probably do every 3 to 6 months. And if you're working with any type of carbons or any of the other harder filaments, and you decide to use copper, I would be swapping them out after every couple prints. The copper is going to be destroyed with the carbons. So here I've got a bag of 20 of them. This bag only costs about $8. I think it was $8. It was right around there. So they're not expensive to swap out. So anytime you're having issues, just go ahead and swap them out. That's what I do. That said, if you are going with some of the stainless steel tips, those are much more expensive, so I would only swap those out if I need to. Alright, so now let's take a second to talk about why we're heating this up before actually taking it all apart. The actual metal on the hot end, or the aluminum, as it heats up, it will expand, so it's going to make taking the actual nozzle out easier. And then it's going to prevent any type of possible breakage. I've seen it before where somebody tried to switch out the nozzle on a cold system and it ended up breaking off the tip, and that whole hot end had to be replaced. So let's not do that. Alright, so we are up to 185, so we're good to go here. Let me go grab some tools. First thing we're going to want to do is take this fan off. I'll show you the cover here. I'm using the Allen wrench that came with the set. Alright, so we got the 2 screws out here. Make sure you set them to the side, but don't lose them. And you're going to want to move this over and put it up on the bar here so that it's stable, because the fans are still running, and you don't want to pull on this cable too much here going down to the heating element. Alright, so now that we got that done, I'm going to actually want to raise this so I can work under it. So let's go ahead and raise the Z-axis. I probably should have done that before I took this off, but here we are. Alright, so let's go to prepare, move axis, move Z, and do 10 millimeter increments, and let's do 50, see where we're at. Yeah, that's fine. Alright, so now let's just go back to our menu here. Alright, so next thing you're going to want to do is, if you have the silicone sleeve here for your insulation, you're going to want to remove that. Now be careful because it is hot, so I'll just use this tool, kind of pop it off. It slides out from the one side, but like I said, this block is hot, so this is going to be quite warm. It's actually really warm. So be careful when you're doing any of this. You don't want to burn yourself. I've done it before. It is not fun. All right, so here we're going to want to use pliers and either a wrench that came with the printer like this guy here, or in this case I'm going to use a socket. A 6mm socket fits perfect. So we'll just make sure we're going the right way. We're going to want to grip the block itself, and we do not want to touch the actual cables over here at all. So we'll go in from this side. Yeah, we just want to make sure that the block itself doesn't spin as we remove the nozzle. It's kind of hard to get that to stay. Alright. So then we'll just go in and break it loose. Sorry, I was having a hard time getting the socket in there around the wrench. Alright, after you get a couple turns, you're good there. I'll switch back over to the wrench here just to finish it off. So it just spins freely. Now, make sure you do not touch the tip right now or that block. It's going to be very hot. Alright, so now that we got that out, just set over to the side, cooled off a little bit. Then I'll show you the actual blockage I had in there. Let's go ahead and take out the tubing for the Bowden drive. So let's take this clip off here. A lot of times people don't use this. I have it in there just to be safe, just so things don't slide around. Then you can use the wrench kind of push down on here just to pull this back out. Alright, let's go ahead and pause for a second while this cools down, and then we'll get started. Alright, this has cooled down quite a bit. I can actually hold it. I don't think you'll be able to see this, but that entire tip here is completely jammed. Now, you can try to use the, there's almost like a needle that came with it that's 0.4mm. I still have it on the little foam block. And I've seen people try to use drill bits as well to try to clean these out. The thing is, to me, it's not worth it. I think they cost about 50 cents a piece. If it gets this bad, I'm just going to replace it. Alright, so let's go ahead and set this off to the side here. Alright, so our temperature is still at 185. So let's go ahead and cool it down so we can put the new nozzle on. And then once we get it hand tight, we'll heat it back up. And then slide the actual tubing back in there and then tighten it all down. And you're going to want to go to prepare and just go to cool down. That'll start to cool down the block a little bit so we can work with it. One thing I'm going to want to do once this thing warms up is make sure I can push this guy all the way through to kind of make sure the heat sink and everything is clear here. This fan block is kind of annoying. Alright, so let's go ahead and push this through. You're going to want to verify that you don't have any junk or anything on the bottom, because as it gets fed through, you're going to want it to come out clean and just kind of wipe it up. You might have to do that a couple times if you have any types of jams or anything in here. I'm not sure if I do have a jam. That's why I'm going to want to do this, just because of how bad that nozzle was. So it's basically, I have it all apart. Let's just go ahead and do it. Alright, I have a block in here somewhere. Alright, so I just verified that there is some filament that's jammed in there. I can't get the tubing through, and I shined a light on there. I can't see through, and I can see the filament that's jammed. So what I'm going to go ahead and do is heat this back up, but I'm going to want to heat it beyond the 185. I'll probably go to like 210 or 212 just to try to liquefy the filament as much as possible. So let's go to control, temperature, nozzle, and let's do 212, 210, somewhere around there. Yeah, 211 that works too. Alright, so let's give this a second to heat back up. And then again, while that's going, make sure you guys smash that like button and subscribe. Alright, we are back up to temperature. Sorry about all the splits in the video. I was trying to eliminate a lot of the dead time, just waiting for the hot end to heat up and cool down. Alright, so let's go ahead and try to push the tubing through again. It should be easier now that it's hot in there. So let's see what we got. Alright, that is not going through. So now what we're going to end up doing is I'm going to let this cool back down. Then I'm going to take this the hot end off here and then take a look, see if I can get another tool to push through. So let's go ahead and let that cool down. Alright guys, we're back. We're down to about 35 degrees Celsius, so we can go ahead and get started. What we're going to want to do here is take out these two screws, and then this whole unit will drop down, and then we can take a look inside to see what's going on. And actually I'm going to turn off this as well, just so we don't have any issues. Alright. And again, we're going to want to be very careful when it comes to our heating element here. We do not want to knock that off, or the actual thermostat sensor. It will mess with the actual temperature readings and could potentially cause fires. Alright, so what do we got here? Alright guys, that ended up being more work than I expected. The entire thing was pretty much clogged. Here's a piece of the plastic I ended up having to take out. I hate doing this, but I ended up having to use a drill to actually get this out, so that was not fun. But let's get back to the purpose of this video. Let's go ahead and put this back together, and then we'll put the new nozzle on, and then we'll be good to go. Alright, so again, we got to be careful with the cables going to the hot end here. Alright, sorry about all the jumping around here. Just trying to eliminate the wasted time on the video. Alright, there we go. We are almost nice and tight. I hate this fan. I believe on the previous model you didn't have the side fan, so it's easy to actually set this up here. But now with both of the fans, the cables just keep getting in the way. Alright, so we'll tighten this up a little bit here. Alright, now let's go ahead and heat this back up. We're going to want to go to probably 210 or so, just to get it above the normal temperature, so that when we do put everything back together and it cools down, we got a good solid connection. Alright, so let's go to control, temperature again, go to nozzle, let's go up to 210 and hit enter here. Not 240, my bad. Alright. And anywhere around that temperature is really fine. The main thing is you're going to want it to be above the temperature you normally run. So if you're running PLA 210, 220 or so, it's fine. If you're running ABS, you're going to want to go higher. While it's still cool, let's go ahead and get the nozzle in here. And then just start turning it a little bit. I'm just going to use my socket to turn it. We just want to get it hand tight at this point. And again, we are working with very hot material here. Be careful. Alright, there we go. Just hand tight. And let's give it a minute to heat up, and then we'll continue. Might as well just leave it down there. Don't want it hanging, but it's better than it falling around. Alright, so let's loosen the nozzle a little bit, just a tad, maybe a quarter turn here, and then make sure that we can push this down a little bit more. We want to get the tube pretty much right on that nozzle so we don't have any gaps in between. Now that we've got a good solid base, we can go ahead and tighten this back up. Again, we're going to want to use our wrench here just to make sure that we're not moving this block. Now you want it tight, you don't want to over tighten it. So I'll just go a little bit there. It's easy if you're using a socket or a wrench, or a decent wrench, not like one of these, to over tighten it, so just be careful. Once it's snug, just give it a little bit more and then go ahead and stop. And let's go ahead and put on our silicone cover. If you're using the older version of the Ender 3, I believe it just has the insulation wrap on it, so you don't have to worry about this. If you do have that, I recommend you switching over to one of these silicone sleeves. It's a much better insulator. Alright, so this will just go on here, pop it into place, and then I don't want to burn myself here, so I'll just use that to get in the corner. And we can go ahead and put our fan back on here. We want to be careful with these cables again. I really hate moving those cables around. Alright, we're pretty much in place here. Just grab one of the screws. Get this guy ready to go. I was getting caught there on one of the cables for a second. Sorry about that. And I hate working with these tiny screws. Almost in a second hand. Alright, that one started. Next one will be much easier. I don't have to try to hold the fan in place here with the outer cover. And then we just want these snug. We don't have to over tighten them. And now that we got that, we're already up to 210, so let's just go ahead and feed our filament through, get that loaded, make sure we're good there. And as we can see, it's coming through nicely now. Perfect. So that's pretty much it. Now we can just let it cool down. Let's go to prepare, cool down, or you can just turn it off and let it cool itself down. It's up to you. I just like using the fans, it speeds it up a little bit. But yeah, that's all there is to it. Make sure you guys smash that like button and subscribe. And also go ahead and leave a comment on how you handle this. Have you had blocks that have been this bad that you've actually had to take everything apart? I think I know what caused this. It was me being dumb, just playing around, experimenting with different things. But I'm just curious, who's had blocks like this? How often do you switch out your nozzles? Do you ever use anything besides our brass nozzles like these? Or, I mean, do you think it's worth spending the extra money on your stainless steel nozzles? I mean, those can get quite expensive, so I just want other opinions. To me, for a standard PLA, I don't think it's worth it, but if you're printing a lot of carbons and stuff, it might be. So go ahead and leave a comment below, let me know what you think, and I'll make sure to reply to everybody. Until next time, have a good one.